start your snap on chemistry for BPSC assistant professor. So my first question is that which theories are based upon the hybridization?
Sir, please repeat.
Which theories are based on the hybridization?
Valence bond theory.
Okay. What is the benefit of hybridization?
From hybridization, we get equivalent energy orbitals.
So I'm asking about the application of hybridization, not what is hybridization.
By using hybridized orbital, we form a molecule. There is overlapping of hybridized orbital of central atom with atomic orbital, yeah, hybridized orbital.
Do you know any application? I am not asking about the what is process, what is hybridization. I am asking about the application of hybridization.
Yes, sir. By hybridization, we know about geometry of the molecule. With the help of hybridization, we determine geometry.
We cannot find shape.
Yes, shape is founded by Vesper theory mainly.
By hybridization, we cannot find shape. We can find only geometry.
Yes, sir. Only geometry.
Okay. Hybridization is prior to the bond formation, or it is after the bond formation?
Hybridization occurs before bond formation.
Is there any molecule which is 100% ionic?
Yes, sir. No any molecule is 100% ionic. Like only cesium fluoride, which is very close to 100% ionic character, but it is also about 94 to 95% ionic character.
Which is the weakest interaction between the atoms?
Dipole interaction is weakest interaction, also called London force or London dispersion force.
How it varies with the distance?
1 by r पे power 6 है.
Strength, weakest bond?
G.
Which is the weakest bond?
Weakest bond is hydrogen bond is very weak bond. But in physical or chemical? Sir, please mention physical bond or chemical bond.
Which is physical bond, which is chemical bond? Can you tell me?
Chemical bond is ionic, covalent, and coordinate bond, while physical bond is hydrogen bond and van der Waals force of attraction. In van der Waals force of attraction, induced dipole is weakest force of interaction.
Okay, what is the range of the, if you have to break any hydrogen bond, then how much energy we will need required?
About 8 kilojoule per mole to 42 kilojoule per mole, which is about 1/10 of strength of covalent bond.
Okay, if I want to break a bond between HH molecule, in a hydrogen molecule HH bond, I have to break.
Yes, sir.
How much energy I will require?
HH bond is the strongest bond among all single bond forming elements. So it requires very higher amount of energy, but exact data, sir.
Exact data you don't know.
Yes.
What are rare earth elements?
Pardon, sir.
Rare earth elements. What are rare earth elements?
Rare earth elements are these are called lanthanide metals. Yeah, 4F series metal.
Why they
Cerium
are
to
called
cerium.
rare earth?
Yes.
Why they are called rare earth metals?
Initially, these elements, scientists know these elements are present in a very poor amount, yeah, traces amount in earth crust, so called rare earth metal. But now these days they are not called rare earth metal because some of the element are present in more amount in earth crust. So the rare earth metal is old name of these metals.
Okay. Among the metals,
Yes, sir.
they form the metallic bonds.
Yes, sir.
What geometry they adopt?
What geometry?
Yes.
Metallic bond. In metallic bond, there is no geometry because there are two concepts of
If
metallic bond.
if they are present in a crystal form, then in which form they are present in crystal form?
सर समझ नहीं पाया क्वेश्चन क्या है.
Metals are present in crystalline forms.
Crystalline form.
Yes. In crystalline form, what geometry they adopt?
ये मुझे क्वेश्चन क्लियर नहीं हो पा रहा है.
Okay. What do you know by Bravest lattices? Bravest lattices.
Previous.
Bravest lattice.
Bravest lattice. सॉरी सर अभी पूरा याद नहीं इसके बारे में, थोड़ा देख जी.
Okay. Which are better reducing agents, D block or S block?
S block, because they have lower ionization enthalpy.
Amongst the S block, which will be the strongest?
In aqueous medium, lithium, while in anhydrous condition, cesium.
Atomic number of cesium?
जी.
Atomic number of cesium?
55.
Cesium का? Okay,
Yes, sir.
KMnO4 is a colored compound.
Yes, sir.
Why it is colored?
Due to charge transfer transition.
What are these charge transfers?
In charge transfer transition, since oxide ion have completely filled 2p and Mn has D0 configuration, so there is transfer of electron from 2p to 3d during excitation process, and during de-excitation electron return from 3d to 2p orbital of oxygen. So there is electronic transition between oxide ion and Mn+7.
What is the oxidation state of Mn in the KMnO4?
+7.
+7. Okay, cobalt form two coordination complexes in coordination number 4 and coordination number 6.
Yes, sir.
But in coordination number, it is a dark blue. But in coordination number 6, coordination number 4, it forms a dark blue complex.
Yes, sir.
In coordination number 6, it forms a light pink complex.
Yes, sir.
Why it is so?
It depends upon the value of CFSE. So by CFSE, we can determine the value of lambda, or if lambda is shorter, then intensity of color is lesser. If lambda is more, then intensity of color is more.
Okay, it depends upon CFSE.
Yes, sir. Or CFSE depend upon geometry of the molecule, the geometry of the complexes.
Any other factor on which CFSE depend?
CFSE also depend upon magnitude of charge on cation, central metal ion and ligands. Also, when we move from 3D to 4D series, the CFSE increases from 30 to 50%, and when we move from 4D to 5D, it also increases 30 to 50% CFSE. Or it also depends upon a strength of ligand. Stronger ligand form more stable complexes, so the magnitude of CFSE is greater.
Okay,
There
which theory explains about the different type of a ligands in the coordination complexes?
This theory.
Which theory explains why some ligands behave a weak ligand, why some behave a strong ligands in coordination complexes?
Valence bond theory.
वैलेंस बॉन्ड थ्योरी ने एक्सप्लेन किया था
जी,
वैलेंस बॉन्ड थ्योरी ने एक्सप्लेन किया था। एलएफटी के बारे में कभी सुना है? एलएफटी के बारे में सुना है कभी?
यस सर, यस।
लिगेंड फील्ड इसने क्या किया था?
लिगेंड फील्ड थ्योरी सर, ये आइडिया नहीं सर।
ये आइडिया नहीं आपको? ओके, एनी नेचुरल अकरिंग कोऑर्डिनेशन कॉम्प्लेक्स?
Vitamin B12 is naturally occurring complex.
Which metal is present?
Cobalt metal.
Cobalt metal.
Yes sir.
Okay. What is biological importance of sodium?
Biological importance of sodium?
Yes.
Helps in nerve conduction, sodium and potassium, also regulating blood pressure.
One famous catalyst which is used for the hydrogenation of alkenes.
Wilkinson catalyst. Triphenylphosphine rhodium chloride.
Okay. Can you name any anti-cancer drug?
Cancer drug, cisplatin.
Cisplatin.
Yes, sir. But it is dangerous to kidney, damage kidney. Yes, sir. So caproplatin is now used.
Okay, okay. Can you give examples of some hard bases?
Sir, pardon, please.
Can you give examples of any hard bases?
Hard bases are like those bases which are smaller in size and high charge magnitude, like N3 minus, OP2 minus, F minus. These are hard bases. Hard to donate.
Okay. What are oxo acids?
Oxo acids are those acids in which hydrogen is directly linked with oxygen atom, like H3PO4, H3PO3, H2SO4, HNO3.
Okay, if we consider the oxo acids of phosphorus, H3PO2, H3PO3, yes, can you draw the shape of these acids?
All these have tetrahedral shape.
Can you draw? Presently you are having any pen or paper?
Yes sir, I have whiteboard also. I am in classroom.
Okay, can you draw these?
Sir, yes. Yes sir. चलो आप लोग बैठ जाओ ना। यस,
हाँ जी, ड्रॉ करो।
H3PO3. Yes sir.
Next H3PO4. And tell me which is the strongest acid from all these.
S3PO2.
Why?
S3, because in these two acids, S3PO3 and S3PO4, there is intramolecular H bonding which interfere in removal of H plus ion. So S3PO2 is most acidic. There is also
in which compound intramolecular hydrogen bonding is present?
In S3PO3 and S3PO4 intramolecular H bonding is present.
Okay.
Yes, sir. Also, we can say this about in S3PO2 the dissociation constant is highest, but it is experimental data. Theoretically, we can explain it by intramolecular H bonding. In S3PO4, I can write this structure S3PO. OH delta minus and delta plus, there is, this is the intramolecular H bond. Yes, sir.
Oh, okay, good. Okay, in IR spectroscopy,
yes, sir.
What will be the range of the metal oxygen bond?
IR spectroscopy का range है
of metal oxygen bond. If any metal oxygen bond is present in a compound, at which wavelength the peak will be observed?
Sir, wavelength, sir, no idea, sir.
In alcohols, any idea for OH bond?
Sir, एग्जैक्टली वो डेटा मुझे याद नहीं है सर अभी.
Okay, for what purpose the ultraviolet spectroscopy we use?
UV for changing ultraviolet spectroscopy
For the nitrogen fixation.
Yes, sir.
Which catalysts are used?
Nitrogenase.
Nitrogenase is composed of which metals?
Nitrogenase, iron containing metal, iron.
Have there some specific names?
No idea, sir. About this.
No idea. How we can qualitative analyze the presence of metals in a compound?
By color as well as elimination of by change in color as well as elimination of some gases.
If metal is present, how the gases will eliminate?
No, sir, mainly changing in their colors.
कैसे कलर कैसे चेंज होगा?
कलर जैसे मैं कोई सॉल्ट एनालिसिस
ओके,
सपोज कि मैंने कोई सॉल्ट एनालिसिस किया, लाइक फ्लेम कलर टेस्ट ही किया अल्कली मेटल का, या बोरेक्स बीट टेस्ट किया है, तो हमें कॉपर के केस में जैसे ब्लू कलर का बीट मिल रहा है, में सोडियम गोल्डन येलो कलर का वेपर दे रहा है. तो
okay, you have said that in borax bead test the copper will give red beads.
नहीं, कॉपर गिव ब्लू कलर बीट CuBO2 का होल ट्वाइस.
why the blue color beads are appeared?
Sir, please repeat.
Why this blue color beads are appeared?
Due to formation of copper metaborate, and the main reason is that excitation and de-excitation of electrons from metal ion.
Okay. Any spectroscopic technique which we can use for determination of metals?
Determination of
Metals. Any spectroscopic technique we can use?
mass spectroscopy.
मास स्पेक्ट्रोस्कोपी से तो हम ऑर्गेनिक मॉलिक्यूल्स फाइंड करते हैं.
So then, sir, Mossbar.
Mossbar? What is this Mossbar?
Mossbar spectroscopy, gamma radiation is used.
Okay. We can find only 2 or 3 specific metals from the Mossbar. You can name that 2 or 3 metals.
Iron, cobalt, cobalt, iron, दो मेटल.
एक और भी होगा.
एक 3 SN, I hope SN is used.
Okay. In Mossbar spectroscopy, which element is used for excitation purposes?
Cobalt 60 is used.
Okay. Okay, Harinder. Now I am giving you the feedbacks of your interviews.
Yes.
Okay, your interview was good. Okay, your confidence level is also good. Okay,
sir, क्या बोला? सुनाई नहीं दिया sir.
I am saying that your confidence level was good.
Yes.
Okay, you gave a good answers of many questions, but few questions you answered wrong also. Because suppose first question I have asked you about the theories of the hybridizations.
Yes sir.
ठीक है. वैलेंस बॉन्ड थ्योरी आपका ठीक था आंसर, बट जो ज्योमेट्री और शेप की बात आई, तो ज्योमेट्री और शेप दोनों ही थ्योरीज बता सकती हैं हमारे को. वैलेंस VSCPR भी बता सकती है और VBT भी बता सकती है. ज्योमेट्रीज और शेप्स में डिफरेंस यही होता है. ज्योमेट्रीज में हम लोन पेयर इंक्लूड कर लेते हैं, शेप्स में हम लोन पेयर को छोड़ देते हैं.
जी जी जी.
ठीक है. और हाइड्रोजन बॉन्ड आप कह रहे थे फिजिकल इंटरेक्शन है. इट इज नॉट अ फिजिकल इंटरेक्शन. फिजिकल बॉन्ड्स नहीं होते, फिजिकल इंटरेक्शंस होती हैं. बॉन्ड हमारे पास एक ही रहता है, केमिकल बॉन्ड. ठीक है. फिजिकल्स जो होती हैं दैट आर इंटरेक्शंस, नॉट अ केमिकल बॉन्ड. ठीक है. उसके बाद कोऑर्डिनेशन पे आ जाते हैं. कोऑर्डिनेशन में आपने जो कहा था मेरे को, क्या कहते हैं, CFSC पे के ऊपर डिपेंड करता है. ठीक है. दैट इज नॉट डिपेंड्स अपॉन द CFSC, दैट आल्सो डिपेंड्स अपॉन द सिलेक्शन रूल ऑफ द ट्रांजिशंस.
यस सर, यस सर, यस सर. वो एक्चुअली हाँ बिल्कुल बिल्कुल लेपोर्टे और स्पिन
लेपोर्टे. In coordination number 4, geometry is tetrahedral. ठीक है. And that Lepote is allowed transitions, but in coordination number 6, Lepote is forbidden.
Yes.
So that why it shows a pink color. ठीक है. LFT ligand field theory जो है, that is very important. उसी ने ही बताया था हमारे को about the nature of the ligands. VBT ने नहीं बताया था हमारे को. ठीक है. VBT की तो limitations हैं ये. It does not explain the nature of the ligands. It just gives a theoretical explanation on the basis of magnetic moment. ठीक है. LFT और मॉलिक्यूलर ऑर्बिटल थ्योरी. अगर जॉन टेलर इफेक्ट के बारे में मैंने नहीं पूछा क्योंकि मेरे को लगा आपको नहीं पता होगा. ठीक है. आपका +1 +2 लेवल दैट इज वेरी गुड. ठीक है. बट जब हम BSc MSc पे जाते हैं तो वहां पे प्रॉब्लम आपकी.
यस सर.
ठीक है. क्योंकि अब जो इंटरव्यूज आप फेस करने जा रहे हो वहां पे MSc और BSc का ज्यादा पार्ट रहेगा.
अच्छा.
ठीक है. क्योंकि यू आर गोइंग फॉर असिस्टेंट प्रोफेसर. यू हैव टू टीच BSc क्लासेस, तो उसमें आपका MSc और मतलब जो ये टॉपिक्स हैं, कोऑर्डिनेशन हो गया हमारे पास, ठीक है, ये आप मतलब कि जो इनका मेन पार्ट है BSc और MSc का देखना शुरू करो।
ठीक ठीक।
स्पेक्ट्रोस्कोपीज बहुत इंपॉर्टेंट हैं, ज्यादा क्वेश्चन स्पेक्ट्रोस्कोपी से ही रहेंगे, ठीक है। 11th-12th से बहुत क्वेश्चन या 1-2 ही रहेंगे, ठीक है, ज्यादा क्वेश्चंस आपके स्पेक्ट्रोस्कोपी से बहुत क्वेश्चंस रहेंगे आपके। IR स्पेक्ट्रोस्कोपी भी इंपॉर्टेंट है, UV इंपॉर्टेंट है, ठीक है। इनमें पीक्स रेंज जो मेन रेंजेस हैं वो आपको याद ही रखनी पड़ेगी, ठीक है। UV में क्रोमोफोर्स, ऑक्सोक्रोम्स क्या होते हैं, ठीक है, अनसैचुरेशन का क्या इफेक्ट पड़ता है, ठीक है, ये आपको देखना पड़ेगा। उसके बाद एटॉमिक एब्जॉर्प्शन स्पेक्ट्रोस्कोपी इज वन ऑफ द मेजर टेक्निक टू फाइंड आउट द क्वांटिटेटिव एनालिसिस ऑफ मेटल्स। AAS एटॉमिक एब्जॉर्प्शन स्पेक्ट्रोस्कोपी, और एक और होती है इंडक्टिव कपल्ड प्लाज्मा स्पेक्ट्रोस्कोपी, ठीक है, ये दोनों मेजर्स रहती हैं। उसके बाद एक और भी होती है फ्लेम फोटोमेट्री। इनके बेसिक प्रिंसिपल्स, बेसिक एप्लीकेशंस, क्या इंस्ट्रूमेंटेशंस रहती हैं, ये भी देखो आप, ठीक है। यू गिव अ स्ट्रेस ऑन द BSc एंड MSc लेवल, +1 +2 आपका, मेरे को आपका ठीक लग रहा है,
यस सर,
ठीक है।
यस सर।